Hi guys. As you can see, I'm not here today. So we have a guest teacher with us. I'm going to try to run class the same as I would if I were there by video. So you're going to be pausing, thinking, participating, writing, and getting involved in class. Be prepared to do that because you want to treat the guest teacher like a guest in our home. Make them comfortable, get them involved, keep the class going just like you would if I was there. We also have some new students joining us in both my 7th and 8th hours. So please make sure you're welcoming, help them get what they need, fill them in on what's going on in an appropriate way that isn't disruptive to class. So for class today, you should see that you need your book, a pencil, and 2 colored pencils. What we're doing today is mostly drawing, so 2 colored pencils will work just fine. I want to be clear about what's coming next before we start, but first I want everybody to be ready. So go ahead and pause the video, and if there's anything you need, quickly, quietly, appropriately, get up and grab it. All right, I'm back. So let me explain where we are and where we're going. Today we're going to work on coming to consensus. We're going to create a consensus model based on the models you created on pages 50 and 51 yesterday. The good news is this is going to be a really easy process because I've looked at your models. They look fantastic. We agree on most everything. So we're going to go through this pretty quickly. Once we finish our consensus models, we're actually going to be conducting a lab. Just like the lab where we compared the 2 clear liquids, we're going to be comparing 2 invisible gases based on their properties. Remember, how well you behave and how you show me you can handle some dangerous materials and some real science will determine how you do the lab. We can do the lab one of 3 ways. If you're safe, appropriate, and you do a great job, it's a you-do lab, meaning you as a group will complete all the parts of the lab on your own with a little bit of direction from me. I also have the lab on video. So if any of you have a really hard time with how you're behaving in the lab, I'll send you back to your seats. You'll complete it on your own while your group continues on without you. If as a whole class you're not being safe, then what will happen is I'll send you all back to your seats and it'll become a demonstration, which is I do and you watch. Then after we've compared these 2 invisible gases, I'm going to show you a third. I'm showing you a third because it does something interesting and somewhat dangerous. Once we see this third gas, we're going to learn about a disaster that was caused by this gas. And based on the evidence that you've seen and the disaster that you learn about, you're going to come up with an argument in writing about what you think happened. So, just to review, over the next 6 days or so, first, today we're going to come to consensus and create our consensus model. Then we're going to investigate 2 invisible gases. Then we're going to investigate a third, slightly more dangerous gas. Then finally, we're going to look a little more closely at that gas and see if its properties could make it responsible for a horrible disaster that occurred about 70 years ago. So, once we complete all that, that should take us to the middle of next week. Also remember that your behavior for the guest teacher today will have a huge impact on whether or not you're able to do the lab. Okay, we're about to move on to the next part. Okay, so now please turn in your book to page 52. It looks like this. Down here, you'll see a picture that at this point you're very familiar with. Our goal for today is to create a new consensus model. If you remember, the last time we came to consensus was on October 17th when we made our chocolate chip cookie model of science. We're moving on from that model because we now have new information. We know things are different. We're going to create a new model that we can agree to moving forward. I'm going to pause the video, and I would like for all of you to write our consensus model and today's date at the top of your page. I would also like you to look over what you're going to include in your model, and I would like for you to explain to our guest teacher what consensus means and what we do when we create a consensus model. All right, now that you've discussed that, here we go. So again, consensus means we all agree. So this is going to be easy because I've looked at your notebooks and it looks to me like we do all agree. So in this space down below, we're going to create a consensus model based on everything we've seen so far. And remember, there are lots of things we know. We know air has mass and volume. We know it takes up space. We know it fills the space evenly. We know all matter is made of particles. And then we now know that there can be two different kinds of particles. There's an equal amount of empty space between the particles, and the particles are always moving. So those are the things we're going to include in our consensus model. I'm going to draw the model maybe differently than you do. However, what should end up happening is that even though our models might look different, they all represent the same things, and in the end, we all agree. So the first thing we need to decide is how we're going to represent our particles. I'm going to pause for a second and create here. Actually, I'm going to label this. I'm going to put in letters right over here in the side of my margin that this is going to be my key. And I'm going to use this space as my key. I'll make it red so it stands out. You can use one of your colored pencils if you want. But this over here, this list, is going to be our key. Now what I want you to do after I pause is I want you to draw right in this space right here an air particle, and in this space right here an odor particle. I'm going to draw mine while you're waiting. All right, so I've drawn a little blue air particle and a little red odor particle. I made them small, I filled them in. Remember, you can use different shapes, use different colors, whatever you choose. The most important thing is that you have two particles and they're different. The air particles, we all agree there's air in the room. The odor particles are the cinnamon particles that come from my smell jar that we smelled yesterday. So, sorry for the interruption. I got, somebody came in just there, so sorry for the jump in video. Okay, so here's how I drew my particles. Again, blue and red. Now, when I draw my particles in my model, I have to remember to leave empty space. We know when we compressed the air that there's way more empty space than there are particles because we were able to compress the air down to about 1/3 of its size. So I'm going to remember that when I draw. The next thing I'm going to do is I need to come up with a way to represent that my particles are moving. I'm going to pause the video really quickly and I want you to add something to your model that shows that your particles are moving while I add mine. All right, so I added an arrow. Now we talked about how you could add the arrow or you could do the little zoom marks behind the particles. All that's fine as long as you're representing that the particles are moving. I personally like the arrow because it shows direction, and by changing the size of the arrow, I can show that changes in speed. I can also, by making the arrow bent, show that things are bouncing off each other. So as we move forward, I'm kind of going to stick with the arrow because it represents some new ideas that I might want to include in my model. Okay, so now what we're going to do, in a second, we're going to pause the video again. And in this space, you are going to use your key to create your model while I create mine. So you go ahead and create yours, I'll create mine, we'll pause, then we'll look at them together and see how they look. Okay, pause. All right, so my model's finished. Here it is. I included the red dots to represent the odor, the blue particles to represent the air. I included the arrows to show that they move equally out in all directions to fill the space. Some things my model doesn't show is it doesn't really show the speed that they're moving, and I'm not really sure that I chose the right amount of odor compared to air. I just know that they're both there. So that's one thing I'm not sure about that I might want to improve. I also am not really sure with how these particles look. So I drew them as dots. As we learn more about particles and what particles look like, they may change. But for now, hopefully we can all agree to this model moving forward because we've got some important work to do when we start comparing these two invisible gases. So again, like I said, you guys are going to create in the lab two invisible gases, and you're going to compare them based on their properties. So there's kind of a trick there because when we compared the clear liquids, There's lots we could do to compare them based on their properties. They had a different odor. We could dip the pH paper in and see different things happen when we're comparing solids, that we can tell how they feel, how they look, all sorts of things. Gases are a little more tricky. So I'm going to pause the video for a second, and I want you to discuss with your guest teacher why it's hard for us to compare gases. Okay, go ahead and discuss. Why is it hard for us to compare gases based on their properties? All right, great. I hope you had a really good discussion. Some of the things that some of my other classes have come up with are that you can't see them, you can't feel them. The gases that we're working with are carbon dioxide and oxygen. So we know they have no odor, and they're very difficult to compare. They're things that we're used to being around us all the time. They're in the air in this room right now, kind of mixed together, and so they are really difficult to compare. So I'm going to pause the video again, and I want you to discuss what are some things that you could do to compare them. Be creative. This is tricky. Think about what we could do to compare gases. Have a good discussion. See what you come up with. Okay, hopefully you paused there. If you didn't, pause now and then pick up here when you're done with your discussion. Okay, so some of the ways you can compare gases are interesting. Some of the things we've done with gases before we could use to compare them. We could take an identical amount and test the weight. We could see how well they compress or expand. But that's going to be tricky because when you can make a gas, it's hard to catch it. And it's also hard with something that you can't see to tell that you have an identical amount. So that's actually not what we're going to do. We're going to conduct what's called a flame test and compare them based on the property of their flammability. I'm going to pause the video again, and I want you to discuss what you think is involved with a flammability test. Okay, hopefully you paused back there. If you didn't, pause here. But you probably came up with the right answer. We are going to create these gases, and then we're going to light them on fire. And we're going to see, based on their flammability, what happens. So, this is going to be an interesting lab. We're going to be working with some tools we've never been working with before. We're going to use a baking soda and vinegar reaction to create carbon dioxide gas. We're going to use yeast and hydrogen peroxide to create oxygen gas. Once we've created these gases, we are going to use wood splints, lit on fire, put into the space where the gas is to see what happens, to see how flammable they are. The third gas we're going to compare is hydrogen gas, and I'm going to do that one because hydrogen gas is a very interesting thing when you introduce flame to it. A flame test is a really common test that scientists use all the time to compare different things because something's flammability tells us a lot about what it is. If you remember all the way back to the beginning of the year when I lit the table on fire, the two clear liquids that I compared looked almost exactly the same in all of their properties, but clearly behaved very differently when I conducted that flame test. So again, remember, when you do this lab tomorrow, there are a couple different ways you can do it. It'll probably take us maybe more than 2 days to conduct the lab. If at any point during those days that you show me that you can't handle it by following the 9 lab safety expectations, things will change for you. You'll conduct the lab on video without being a part of a lab group and having hands-on materials. If as a class you show me you can't handle the lab, then everybody will sit. I will conduct the lab and create the gases and you will watch. So hopefully you're excited about that. It's going to be interesting, and I'm sure you guys can do your best. So hopefully, even though this video was a little jumpy, I created it kind of at the last minute. Hopefully you did an excellent job following along with your guest teacher and showed a ton of respect. And I'll see you all tomorrow, and we're going to have some fun. So show me you can be safe, respectful, appropriate, and work hard. All right, here we go. One thing I forgot to say is if you have extra time left over, you should use that extra time to work on pages 50 and 51 or page 46. So go back to those pages and work on them if you're not completed yet. All right, see you guys tomorrow. Bye.